Hello, this is Captain Chaudhari. I was doing with you the stability numerical, the basic stability numerical, and we were talking about the list. Here is the situation of suspended weights. When a weight is loaded or discharged by the ship's crane, right? There is a moment where during the loading or discharging operation, the list becomes very high. We are trying to find out what is that moment when the list becomes maximum in the operation and why the list is maximum at that time. So let us do this question. This question is about a ship of displacement 18,000 tons, km 8.9 kg 7.5 meters. It's upright. A weight of 50 ton is to be loaded by the ship's crane. The zip on the ship's crane is 30 meters above the keel. The weight on the weight on the wharf is placed 14 meters from the center line on the port side, right? And finally the load has to come at a kg 3 meters and 5 meters to the starboard on the ship. It is required to find out what is the maximum list that will happen during the operation and what will be the final list once the weight is loaded on the ship. So let us draw this picture. Let us say you have a ship over here and here is a wharf, and maybe this is the water level. Here's a crane and over here this is a crane, and it seems this upper part is 30 meters above the keel, and the outreach of the jib is going to be, which means that the weight is at a distance of how many meters? 14 meters on the wharf. So what happens is, during the loading operation, and final point of loading would be probably over here, right? And this is something like 5 meters on the starboard side. So we are seeing the ship from the front. This is 14 meters to the port, and the final loading point is 5 meters to the starboard. Now we must understand that when the weight is hanging by the ship's crane, the weight suddenly moves over to the tip of the crane, that is the jib of the crane, and we say that this weight, as soon as it is lifted even by a centimeter, the weight is shifted to the tip of the crane, right? So that is the moment that the center of gravity of the ship would move upwards, right? It means that throughout the operation, whenever the weight is suspended, it is not resting, it is suspended, the center of gravity is at the highest position and the GM is minimum. So we will find out what is the minimum GM during the operation. So in order to have a maximum list, what we want is the GM to be minimum and listing moment to be maximum. So GM will be minimum when the weight is suspended, and listing moment will be maximum when the weight while suspended is maximum distance from center line. Or otherwise also, the listing moment, the weight may not be suspended, the weight might be kept on deck. So long as the distance from the center line is maximum, the listing moment is maximum. So what we will do now is we will try to find out what is the GM of the vessel as the weight is lifted. So we'll do the listing by moment calculation. The first column is weights, that is a tons, and then we have kg, that is a meter, and the third column is vertical moments, that is tons meter. So when we And we can also simultaneously make two more columns, that is the port listing moment and the starboard listing moment. Both are tons meter. So the displacement of the ship is 18,000 tons. kg is 7.5 meters. The port listing moment and starboard listing moment at the moment are 0. As the weight gets lifted as the weight gets lifted on the wharf, what happens is the weight as if gets shifted upwards to the tip of the crane. So we say that as if the weight is loaded at a height of 30 meters above the keel. And how much is the weight? 50 tons. And this is going to increase the vertical moment by 1500 tons meter. Now we are seeing the ship from the front. Now this weight is on the port side by 14 meters. So listing moment is into 50, that is equal to 700 tons meters. This is the listing moment that is caused. And let us see what is the GM of the vessel. Now 18,000 into 7.5 gives me 135,000 plus 1500. The total vertical moment is 136,500 and the weight of the ship becomes 18050 and the kg therefore is going to be 7.562. The km remains unchanged as 8.9 meters. So the GM is 1.337 or 1.338. So GM is 1.338 meters. So we have a starboard listing moment of 700 tons meter and we have GM of 1.338. Displacement is 18050. We have a standard formula and that standard formula is listing moment is equal to delta GM tan theta. And therefore the tan theta will be listing moment, that is 700 divided by delta GM, that is 18050 multiplied by 1.338. So this gives me 700 divided by 18050 equals divided by 1.338 equals shift tan, gives me the list as 1.66 degrees. So list is 1.66 degrees to port. Now this is the list we get when the GM is minimum during the operation and the listing moment is maximum during the operation. Now next what we need to find out is when the weight is placed on the deck. Finally, when the weight is loaded over here, that means probably the crane will be in this position and the weight is loaded. Now let us see when the weight is finally loaded on the ship, what happens. So when the weight of 50 tons is finally loaded, the displacement becomes 18050. The weight is loaded at a kg of 3 meters. So it is going to add the vertical moments as 150 tons meter. Total vertical moments is going to be 135,150. So 135,150 divided by displacement 18050 gives me kg as 7.487. So kg is 7.487 and we assume that the km remains same as 8.9. Gives me a GM of 1.412. GM is 1.412. Since the weight is loaded on the starboard side, 5 meters into 50, that makes the starboard listing moment as 250 tons meter. Once again, the relationship between the listing moment and the angle of list, that is listing moment is equal to delta GM tan theta. So we have tan theta is equal to listing moment, that is 250, divided by delta GM, that is 18050, multiplied by 1.412. So 250 divided by 18050 equals, divided by 1.412, gives me list as 0.562 degrees. List 0.56 degrees to starboard. So we've seen that when the weight is finally loaded on the starboard side, the list is only 0.56 degrees. But while the weight was just lifted from the jetty, at that moment, while the weight is off the jetty, the GM is minimum and listing moment is maximum, and at that moment, the list was maximum during the entire operation. Now this lesson, this numerical is particularly important for those people who do the loading by own crane on the ship, and towards the end, towards the completion of loading, when only a few slings are left to be lifted. Maybe it is container, maybe it is the logs, the wooden logs. So one of the last slings, when the GM of the ship is minimum because you have loaded maximum on the deck, when we lift the last of the slings, one of the last slings when we lift, the ship tends to heel a lot on the lifted side because of this reason.